In this example, we're going to be factoring a trinomial using the idea of a perfect square trinomial. Before I can do anything else, I have to factor out that negative sign because the first coefficient cannot be negative. So let's factor out that negative sign. Again, when we factor out the negative sign, it changes every sign that I have. Now, if you look inside the parentheses, we first check to see if we have a greatest common factor. I do notice that they all can be divided by 2, but a number that's even bigger is I notice that they all can be divided by 4. So let's go ahead and factor out this 4. So I'm going to factor out 4. That leaves me with 9a squared plus 24ab plus 16b squared. And I'm just going to clean this up a little bit by just dropping that parentheses and making that just negative 4. Now at this point, you could factor this trinomial using the grouping method, which we've already learned, but let's look at something else. What do you notice about 9 and 16? I notice that those are perfect squares. 9 is 3 squared. 16 is 4 squared. So let's try factoring this using the principle of perfect square trinomials. And what I'd like to do is just do it as a guess and check. So let's see what would happen if I make this first term 3a and my second term 4b. And this sign in the middle would determine what sign goes in the middle here. Let's see what happens. I'm just going to FOIL this out to make sure that my answer is correct. First is 9a squared. Outer is 12ab. Inner is 12ab. Last is 16b squared. The two middle terms, since they're like terms, they can be combined. We have 9a squared plus 24ab plus 16b squared. So therefore, this is correct. My answer would be the negative 4 times 3a plus 4b squared. Even if you used factoring by grouping method, you would still arrive at the same answer.